the hyperbola. This is the big difference on the hyperbola, and we already alluded to this a little bit earlier. When we were doing ellipses, you found the sum of the distances. In a hyperbola, you're finding the difference. So you're not adding x squared plus y squared, you're subtracting them. You're finding the difference. And this is the equation. You see this equation? It should look pretty familiar because we just looked at ellipses that had very similar equations. This is kind of the simple equation. This is a hyperbola, which is centered at the origin. So there's no shift on this one. There's no h and k. It's sitting right on the origin, and you'll notice it looks exactly like the equation for an ellipse, except you're subtracting the two quantities instead of adding them. And the other change is that instead of saying c squared is a squared minus b squared, c squared is equal to a squared plus b squared. So there's two sign changes that you make. That's about the only difference. These are the foci, F1, F2. So they are still both inside. So this is the conjugate axis. It's a fancy way of saying this is the line of reflection. If the lead term is the x squared, you have a hyperbola that opens left and right. If you have a lead term of y squared, your hyperbola opens up and down. So you can tell immediately from an equation whether the hyperbola opens up and down or whether it opens left and right just by looking at the lead term or the term that's positive. There's one more thing that we want to talk about, which is asymptotes. And we've talked about horizontal asymptotes, we've talked about vertical asymptotes, and you can see here hyperbolas have diagonal or oblique asymptotes. So one asymptote is the opposite of b over a, and the other asymptote is just plain old b over a. Here's another one, and you know that this hyperbola opens up because the lead term is y. And so this is actually the complete equation of a hyperbola. This is your vertical shift, this is your horizontal shift, this is your vertical radius, this is your horizontal radius, and the slope of your asymptotes are here. See, here's another typo. This is supposed to be a over b, not b over a. See? It's right here, but yet it's different than that. So this is an example of something that you're going to see. And guess what you have to do? Complete the square twice. So you're going to say 4y squared plus 24y plus blank minus x squared plus 4x plus blank equals negative 28. We're going to factor a 4 out of the y term, and we're going to factor, we don't have to factor anything out of the x term. That's awesome. So if we complete the square, we're going to take that 6, divide it by 2, gives us a 3, square it, so we're going to add 9. But we're not really adding 9, we're adding a 36, because we've got to distribute the 4. We're going to divide by 2 and square, so we'll get a 4 here. But we're not really adding 4, we're subtracting 4 because of this negative out front, so that means we've got to subtract 4 on this side. So we'll get 4 times y plus 3 squared minus x plus 2 squared equals positive 4. Divide everything by 4. Y plus 3 squared over 1 minus x plus 2 squared over 4 equals 1. So tell me about this hyperbola. Where is it centered? Negative 3, negative 2. 1, 2, 3, 1, 2. Here's the center. What is it, or what does this 1 mean? The 1 is the vertical radius. Vertical because it's up and down, right? Because it's under the y. So 1 here, 1 here. This is A if you want. This is B. So B is going to be 2. So this is 1, 2, 1, 2. Now if this was an ellipse, we would just connect all these dots, but this isn't an ellipse. It's a hyperbola. So we could come up with the asymptotes by saying what is, in this case, because y is the lead, we're going to do a over b and negative a over b. So what's that, like 1/4 and negative 1/4? So you're going to have maybe one asymptote that looks like this, and another asymptote that's going to look like this. Because y is your lead term, do we have a hyperbola that opens up, down, or left, right, up, down? So it's going to look something like this. What? Did I screw up a sign somewhere? You know what I did wrong though? This should be an x minus 4 here. So this should be an x minus 2. That's what I screwed up. This is actually your y coordinate. Because it was the lead term, you know, we've been having x's as the lead term so often. This is actually the y coordinate, the negative 3. And then the x coordinate comes from this, which should be a positive 2. So positive 2, negative 3 should have been our center. This is the lamp in my living room. And last night I turned it on and I was looking at the shadows and I was like, that's a hyperbola.